is equality of error variances. Second assumptions was normal distribution of residuals. Since we save on standardized residuals, we can check about normal distribution of residuals. To do this, you need to go to Analyze, then Descriptive Statistics, and click on Explore, and then you are to new variables in your dataset named RAS_1 and RAS_2. Import these variables into dependent list and click on Statistics and click on Descriptive and click on Outliers, then click on Plots and click on Normality, Plots with Test, and then click on Continue and click on OK. SPSS reports some tables and some plots about residuals distributions. For example, we see that sconous and kurtosis our residuals for cholesterol and for LDL is a little more than what we expect, and for example, test of normality with Kolmogorov, Smirnov, and Shapiro-Wilks reject null hypothesis, and we can conclude that normal distribution of residuals was not assumed. For example, we see that normal QQ-plots is a little far from normal distributions, and also it's true for LDL cholesterol, especially for LDL cholesterol. Here there is some residuals far from this line, and we can conclude that residuals of this MANOVA is far from normal distributions, and maybe these results affect our reports. But in this time, we assume that a residual of our models are normal and has normal distributions, and continue to interpret results of multivariate in SPSS. But our third assumption is about linear relationship between dependent variables and independent variables. There is a table in SPSS reports named multivariate tests. In these tables, we see that there is a significant relationship between gender as an independent variable and dependent variables. Now we can conclude that linear relationships between dependent variables and independent variables is assumed. Fourth and fifth assumptions in MANOVA is independent observations and multicollinearity. Since in this time and in this tutorial we have only one factors, we don't need to check about multicollinearity, but now I show you the path you can check about multicollinearity in SPSS, and to do that you have to go to Analyze menu and then click on regressions, then click on linears, and here you have to import one of your dependent variables to this place and gender as independent variables. Also click on statistics To check about independent observations, you need to turn on Durbin-Watson and check Durbin-Watson, and to check about multicollinearity, you need to turn on collinearity diagnostics. But since we have only one factors in this MANOVA, you don't need to check about collinearity diagnostics. Then click on continue and click on OK. Repeat again this process and then click LDL to import this place to check about independent observations between LDL and genders. But I can inform you that you can check about independent observation with one of dependent variables, because our participants is similar for both dependent variables. And now you see that in the model summary tables, amount of Durbin-Watsons is 1.85, and since Durbin-Watson's value varied between 0 to 4, and when you have a value ranged from 1.5 to 2.5, you can assume that independent observations is true, and your observations are independent from each other. In model summary about LDL models, Durbin-Watson is 1.85, and in cholesterol is 1.71. Now we can conclude that we have independent observations. And if you want to check about multicollinearity, you need to go to a table named coefficients, and last column of these tables named VIF, means variance inflation factor. And variance inflation factor, or VIF, when value of VIF is near to 1, we assume that we have not multicollinearity, and our hypothesis was assumed. Finally, we have influential outlier assumptions. To check about these assumptions, you can go to data sets, and you see that there is two new columns named COO, means Cook's distance, for first and second dependent variables. You can sort descending these columns to check about values more than 0.5, and if there is a records with Cook's more than 0.5, you can categorize these records as influential outliers. Another way is that you can have a plot with chart builder and line plot, simple line plot, such as make a simple line plot with x-axis and y-axis as a Cook's distance for cholesterols, and also for LDL Cook's distance, similar this. Now we see that for cholesterol there isn't any Cook's distance more than 0.5, and we can conclude that there is not any influential outliers for cholesterols, and also there is not any influential outliers for LDL. We can conclude that the influential outlier assumptions is assumed. Okay, thanks a lot for being with Amaardan. Thanks a lot for subscriptions and like and comments that you sent to us. And this is Amaardan YouTube channels with 140 subscribers and 58 videos. In these channels, we have videos in SPSS, RStudio, Smart PLS, Minitabs, JMovie, and some another statistical programs. Some of videos is in Persian, but you can watch this video with YouTube AI subtitles, and there isn't any problems. But finally, if you have not followed Amaardan YouTube channels, please press on subscribe button and turn on bell-shaped button to be notified about new tutorials. I will try to record new tutorials and practical tutorials about different statistical tags in the futures. Then thank you for subscriptions and for being with Amaardan. Now let's go to training and let's go interpret another tables in SPSS reports.